All right, we're going to use some symbols first. Sample mean. What's the symbol for sample mean?
X bar.
X bar. Population mean. Sample standard deviation. That's S. How about the population standard deviation? Okay. How about sample size? And blank are measurements taken from a population.
Parameters.
Parameters. Those are called parameters. So what we're trying to do in this chapter is estimate parameters. Like here we're trying to estimate the population mean. In the next lesson, lesson 7.4, we'll try to estimate a population proportion. Like what proportion of Iowa teens smoke cigarettes or something like that. Right now we're trying, in this lesson, lesson 7.3, we're trying to estimate a parameter, a mean, of a population. Okay? And to do that, we're going to use a sample mean. We're going to use a t-score or z-score, depending on a couple things. We're going to use a standard deviation, and we're going to use our sample size. Now, first question. How do you know when to use t-scores versus z-scores? Like this formula has t-scores in it. But in lesson 7.2, we use z-scores. Can anyone tell me how? Right. If you don't know the population standard deviation, and n is less than 30, then you have to use t-scores. So you have to use your t-distribution chart. If you know the population standard deviation, or if n is greater than or equal to 30, then you can use z-scores and use your z-chart. So you have to know that difference. Okay, let's go ahead and do number 7, lesson 7.3, which is on your assignment. So if you want to write this down as we go, unless you've already done it. This is on page 366. Page 366, number 7. A state representative wishes to estimate the mean number of women representatives per state legislature. A random sample of 17 states is selected. The number of women representatives shown. Based on the sample, what is the point estimate of the mean? That's our first question. So they picked 17 states in the United States randomly. Maybe they picked Iowa and Alabama and Arkansas and Alaska. They randomly picked 17 states and they looked at how many women were in their state legislatures. Okay, and I'm going to go ahead and full screen now. I've already got the numbers in here, so you can just watch. You don't have to put them in right now with me. But just a quick reminder, to put your numbers in, you push stat and then enter, and you go to your list. You enter all your numbers into your list. You don't have to do that, you can just watch for right now. Then I hit second quit. Then to get my statistics on that list, I push stat, right arrow, I'm going to do one variable statistics. Okay, so push enter, and then if it's in list 1, I could hit second 1. If it's in list 2, second 2, list 3, second 3. If you don't put the L1 there, it'll assume it's in list 1 and pull the data out of list 1. So there's our X bar, 33.353. What would be the label on that? 33.353 what? Women. Yeah, that's how many, that on average, out of the 17 states that they picked, that's the average number of women that are in the state legislatures. About 33 or 34, right in there. Okay? So the first question is, for number 7, based on the sample, what is the point estimate of the mean? So we're trying to estimate what the mean of all states would be. If we went to all 50 states and we looked at how many women are in their state legislatures, we're trying to estimate what that mean would be. What is the point estimate for that amount? What's the best estimate I could use? 33.353. Your sample mean is your best point estimate of your population mean. So this is your point estimate right here. Point estimate is one number that would best estimate the population mean. That would be the first answer on number 7. Point estimate of the population mean. Okay, next question. Find the 90% confidence interval of the population mean. So you're going to have to go, for 90%, you're going to have to go to your T distribution chart, which is on the back of your Z distribution chart. And let's see if I can find it here. And you're going to look up 90% confidence interval at the top. Our sample size in this problem, we'd have to count up, we'll see right here on the calculator, my sample size is 17. If the sample size is 17, what's the degrees of freedom? 16. It's always n minus 1. So our degrees of freedom on this problem is going to be 17 minus 1, which would be 16. So go to your chart. You're going to go down to degrees of freedom of 16. You're going to go over to 90% confidence interval. And that's going to give you a t-score. Anybody tell me what to see?
1.753. Wait, 1.746.
I think it's 1.746. That's called your t-score, t sub alpha over 2. Here's our formula for a confidence interval up here. So we're going to start writing this out. X bar is 33.353 minus your t-score, 1.746, times your standard deviation, which is your S right here, 28.688. Divided by the square root of n, square root of 17. So that'll take care of the left side of our formula. What's the only difference in the right side? Plus. Right, so a quick way to show your work, instead of just having a minus here, let's write plus or minus. Type this in once with the addition sign, once with the subtraction sign. We'll do that. 33.353 minus 1.746 times 28.688 divided by the square root of 17. Then if you want to retype it with a plus, just hit second enter. Go back and change that minus to a plus. There's our two values. Now, our raw data that I put in was in whole numbers of women. So if you're using raw data, how are you supposed to round your answers? Now, if you're trying to find sample size, in other words, if you're trying to find n, then you always round up. But we're not trying to find n here. We know n. N is 17. Here we're trying to find a confidence interval.
The nearest.
You go one more decimal place than your raw data. So the raw data was to whole numbers. So I'm going to round these numbers to the nearest 10. So 21.2 is less than the mean, right here, which is less than 45.5. Label on this would be women. Women legislators. So we're 95% or we're 90% confident that the average number of women in state legislators of all 50 states is somewhere between 21.2 women and 45.5 women. Any questions about that? Now let's read the rest of the question because there's a couple other things they want to ask us. It says, note the population mean is actually 31.72 or about 32. So actually, if we went to all 50 states and found the average number of women, it's actually about 32. So our mean's a little bit high. Okay, we got 33.353 our sample mean. So why is that a little bit high? Anybody have an idea why maybe our sample mean is higher than what the real population mean is? Now, notice, and that's not unusual to have a difference. That's called sampling error. When you take a sample, it's not going to match your population exactly. So let's look at the data quick. Look at the numbers: 5, 31, 18. See anything strange there? 132, right? Now 5 was a pretty low number, but 132, that might be an outlier. What's a high outlier going to do to the mean? Yeah. So it pulled the mean up a little bit higher than what the real mean is. The true mean is about 32, which notice does fall in here. Okay? Now it's a 90% confidence interval, so what that means is that if I went out and picked 17 states, then picked another 17 states, and picked another 17 states, and I did that 100 times, and I found 100 different confidence intervals. 90% of the time, the true mean would fall in 90 out of 100 times, the true mean, which we said was about 32, would fall in the interval. In this case it does, because 32 is between 21.2 and 45.5. But realize, every time you go out and pick a different 17 states, you're going to get a different confidence interval. If you do that 100 times, 90 out of 100 times, the true mean would fall in your interval. If you did a 99% confidence interval, then the true mean would fall in the interval 99 out of 100 times. If we did a 99% confidence interval, would this interval get bigger or smaller? If we want to be more confident, the numbers are going to get further apart, we need to leave ourselves more room for error. So that's right, bigger. Okay? More confidence means you have to leave yourself more room for error. You can shut that off, thanks.